Alright, so in this particular video, I have a few examples for you where I'll show you how to extract corresponding graphs for kinematics. The first example here is you're given an x-t graph, which is a positive diagonal slope. And so it wants us to figure out which velocity graph corresponds to this. So first, when you're given an x-t graph, one of the first essential thing you should be able to do is draw tangent lines. Okay, the slope of an x-t graph tells you your velocity. If it's a tangent line, it tells you your instantaneous velocity. If it's a line that connects 2 points, it tells you your average velocity. So let's go ahead and assess this stuff, okay? The first thing I want to do is I'm just going to draw a tangent line on this line, right? So this is kind of redundant, but if you understand graphs, this what I'm about to do is kind of whack. But if you don't, then it helps, hopefully. This is the diagonal slope, meaning the slope is constant. I like to draw my tangent line from the get-go just across the vertical axis here, just so I can know whether my initial velocity is 0 or not. So while for this graph, the initial position is 0, it doesn't say that the initial velocity is 0, which is a common misconception that folks carry over. Well, how do you know if an object starts at rest? Just draw a tangent line that crosses the vertical axis. If the slope exists, then it's already moving. If the slope is flat, then it starts at rest. But as you can see here, the slope here does exist. It's a positive slope, meaning the object is already moving in the rightward direction. Well, how do I know it's right? Because this is a positive slope. So I'm going to draw a couple more tangent lines. As you can see, each of these tangent line lies on the blue line, meaning the steepness of the tangent lines have not changed. Well, what happens when you draw tangent lines and they don't change? It just tells you you're moving at a constant velocity. Because for an object to speed up or slow down, the steepness of the tangent line has to change. In this case, it hasn't, meaning it continues to move in that direction at a constant rate. So here I've made a few bullets for you to hopefully help you keep in track. Here I put constant slope. Well, constant slope here equals constant velocity, right? Because the velocity hasn't changed. Well, what else can you pull? Well, constant velocity suggests that acceleration is 0. If an object is moving at a constant rate, then it's not accelerating. You know, it's like if you're driving and you're going 60 miles an hour, 60 miles an hour, 60 miles an hour, 60 miles an hour. Well, if someone asks you, are you speeding up or slowing down? Hopefully you can say, well, no, I'm not, because I'm moving at a constant rate, okay? So anytime you see the slope as being constant, the same throughout, you can say that it's moving at a constant velocity, therefore A is equal to 0. The next thing you can also pull out is the direction of movement. Well, how do you know if an object moves left or right? Just look at the slope. Well, all three tangent lines have positive slope, meaning the velocity is positive. So I can say that the object is moving in the rightward direction at a constant rate where acceleration is equal to 0. Okay. Well, let's go ahead and analyze this graph. All right. Choice A here, I know velocity is positive because the red line is above the t-axis. Any value above the t-axis suggests that it's positive. The slope of this velocity graph is 0, so therefore I know acceleration is 0. Let's go to B. All right, so here for B, the red line is drawn beneath the t-axis, meaning the velocity is negative. Well, is it speeding up, slowing down? We'll look at the slope. The slope here is 0, meaning the object is moving at a constant rate in the negative direction. Let's look at choice C. All right, choice C, I know the velocity is positive because the whole entire diagonal is above the t-axis. Well, does the slope exist? The answer is yes. All right, if you look at this velocity time graph, the slope here is a positive slope, meaning acceleration is positive. So therefore I know the object is speeding up. But once again, back to the original question. We're looking for a statement where the object is moving in the rightward direction but doesn't speed up, okay? All right, let's go to D. D here, I know the velocity is negative because the whole entire red diagonal is beneath the t-axis. Well, if you look at the slope, well, common sense tells you this is a negative slope, meaning A is negative, right? So once again, be able to pull out information just by looking at it. Well, let's go to E. E is just saying the red line is on 0, meaning the velocity is 0. Well, if your velocity is 0 and this is flat, A is also 0. So choice E essentially tells you you're remaining stationary. Well, but we're looking for a statement that says V is moving, but it's moving at a constant rate. So I'm just going to start crossing out stuff that doesn't make any sense, right? So I need a velocity that's positive. Let's cross out B. B is saying the object is moving in the negative direction. Even though A is 0, is moving in the wrong direction. So I can cross out B. I need V to be positive, not negative. Well, let's look at choice C. Even though choice C has V being positive, I need an acceleration that is 0, right? But this is saying acceleration is positive, so the acceleration doesn't match, right? Not only that, if you've been keeping up, when an object accelerates, the x-t graph should be like, some sort of curve or a quadratic function, right? Or cube. But in this case, this is a diagonal, meaning it's not accelerating. Now let's go ahead and choose D. Choice D is whack only because I'm looking for a positive velocity and this is a negative velocity, so I can just cross that out. Alright, let's look at choice E. I'm looking for a positive velocity, but this velocity is saying is 0, so I can cross that out. So just by deduction, I go ahead and highlight A. But it also makes sense. Choice A says that the velocity is positive. Why? Because it's above the t-axis. And it's moving at a constant rate because the slope of this line doesn't change. So the slope of a velocity time graph once again tells you A. So V being positive, A being 0 fits with what we need here. We need a V being positive, A being 0. So the answer here is A. Okay. Let's go ahead and move on to this one. For this one, it says which of these position time graphs below represents an object moving only in the positive x direction. So I'm going to go ahead and light only. It says only in the positive x direction. So what does that mean? Well, we're given a bunch of x to t graph. So if you listen to the first one, when you're given a position time graph, the first thing you need to analyze are tangent lines. Okay, the tangent line tells you whether an object speeds up, slows down, moving left or moving right. So let's go ahead and crack out choice A here. Alright, so for choice A, I know the velocity here is negative. Why? Because if we look at the slope of this line, that's just a negative slope, right? So throughout, V is negative because the slope is negative. Let's go to B. If you look at B, initially, if I draw a tangent line, that tangent line is flat. And then if I draw another tangent line, that tangent line is getting steeper, but it's a negative slope. I don't want negative, I want positive slope, right? Because it wants it to be moving in the positive direction. So here it's saying the velocity is negative. Well, if the velocity is negative, then you're moving in the leftward direction, but I need positive x direction. So if I draw another tangent line, right, it gets steeper, okay, but it's still negative. Let's go to C. Well, once again, how do I know if my initial velocity is, negative, positive, or 0 to start? Draw a diagonal or draw a tangent line that extends across the vertical axis. So here's in choice C, I've drawn a tangent line that crosses the vertical axis. Just by looking at it, this slope exists. Well, what is the slope? This is a negative slope, meaning V initially is negative. So if you keep drawing a couple more tangent lines, V here is still negative and it's still negative. But we're looking for an object that only moves in the positive x direction. So keep that in mind as I go through these choices for you. Let's go to D. Well, if you go to D, right, the first tangent line is negative, all right, and then on the right side, all of a sudden the tangent line is positive. But we're looking for an object that only moves in the positive x direction. It's not looking for an object that changes direction. So to me, choice D is it was moving left, it came to a stop, and then it started to turn around. All right, let's go to E. If you can cross out D, then E would also be y. Well, the initial tangent line here is positive. And then on the right side of the graph, the tangent line is also, well, it's usually not also, but it has changed direction. It's now negative. But we're looking just for positive, okay? Let's go to F. If you go to F, once again, draw a tangent line that extends the vertical axis. If you look at the slope, that is a positive slope, and this is the positive slope. And I want to draw another tangent line, okay? That is also a positive slope. Well, the slopes are all positive here. It just happens to be getting slower, okay? But it's still moving rightward. Now, let's look at G. If you draw a tangent line there, that's positive V. It's kind of gradual, so meaning it's barely getting moving. And then this is steeper, which meaning it's speeding up. But V is still positive because the tangent lines here are all positive slope, right? And then if you look at choice H, I drew a bunch of tangent line here, similar to the previous question that I had for you. The tangent line here for H lies on the same line. But the only thing we need to analyze again is the direction of slope. These are all positive slope, meaning the object is moving rightward. So therefore, because of that, I need only answers that have positive direction. So I'm looking for answers that only have positive V's. So the answers that fits are F, G, and H. All three of these answer choices have V that are positive. So choice F says it's moving to the right and slowing down, but it's still moving to the right. Choice G said it started off at 0 and then it speeds up to the right. Okay. And then choice H says it's moving to the right at a constant velocity. Okay. Alright, let's go ahead and do this one. For this one, it says you're given once again an x to t graph, which of the following velocity time graph corresponds to it. So if you look at this x to t graph, draw a few tangent lines here. The tangent line there is 0, so we say v is equal to 0. Once again, because the tangent line of an x to t graph tells you instantaneous velocity. Both of these tangent lines are flat, meaning the instantaneous velocity is 0, which means the object is remaining motionless. Okay. Now, if you go here, you draw a tangent line. Both these tangent lines happens to be negative because that's from left to right, that's a negative slope. But you notice the steepness hasn't changed. If the steepness of your tangent line hasn't changed, it tells you you're moving at the same rate, meaning you're not accelerating or decelerating. Okay, so therefore I can say here constant slope means acceleration is 0. Once again, this is an exit t graph, right? So let's go ahead and do our answer choice A, B, C, D here. So I'm just going to go ahead and mark it up. We're here for choice A. The first part of the graph is V is positive. Why? Because it's above the t-axis. And then careful here. These are graphs that you need to pay close attention to. Okay. Well, this next segment I want to break up is, watch my cursor, so I'm hitting here. Well, how do you know whether V is positive or negative? Well, V is positive because it's still above the t-axis. Well, how do I know if it's speeding up or slowing down? Well, at this point, it's some positive velocity. At this point, it's 0. Well, you were moving right and you came to a stop. Well, so what does that say? It's telling you that the velocity here is positive because it's above the t-axis. However, the slope of this line here is your acceleration, and that's a negative slope, meaning A is negative. Okay. Now I'm going to go down once it crosses the t-axis. If you go down here, this whole entire region, well, this is a velocity time graph. It's now telling you, well, it came to a stop and all of a sudden it moved backward. Well, moving backward would suggest that V is negative. Well, what about it? It stopped and then it's sped up in the negative direction. So if V is negative, A also has to be the same sign, which means it's negative. Okay. Let's go to B. B here, the first segment is saying V is equal to 0. Why? Because it lies on 0. And then if you kept up with part A towards the third segment there, well, if U is 0 and all of a sudden this value here is negative because everything beneath the t-axis is negative velocity. Well, how do you know if it's speeding up or slowing down? Look at the slope. The slope of this segment here is a negative slope, meaning the acceleration is negative. So when V is negative and A is negative, we can say that the object is speeding up in the negative direction. All right, let's go to C. C here is saying V is equal to 0, and then all of a sudden here, right, V is equal to some negative value. But if you look at the slope here is flat, meaning A is equal to 0, right? V, again, is negative because it's beneath the t-axis. A is 0 because the slope of this line is 0. All right, let's go ahead and crack out D, and then hopefully we can cross the answer choice out. Well, here, if you kept up with choice C, it's saying the slope here at the start is 0. Why? Because it lies on the 0 axis. Well, if the slope is 0, it also tells you acceleration is 0. Okay. But now all of a sudden over here, the velocity is positive because it's above the 0 now. But the slope of this line is 0 because, well, that's your acceleration is 0. Now, once again, let's go back to what we need. We need a graph that starts off 0, but we need a graph that has negative velocity, okay, and an acceleration at 0. So let's go ahead and do it. I'm going to cross out A because I need a velocity that's 0 to start. This graph here says the velocity is positive to start, so I can just cross it out. Okay. Choice B, I can cross that out because even though the velocity is 0 to start, I need a negative velocity and 0 acceleration. Well, this is negative velocity, but the acceleration is actually negative. It's not 0. So it fits 2 of 3 conditions. So this is why graph analysis can be difficult for people. You have to make sure everything, fits. Okay. All right. Let's go to C. Well, I need a graph that starts off at 0, right? Or in this case, I did choice D and just eliminate. If you look at choice C and D, both have velocity 0 to start. The only difference between this one is that choice D has a positive velocity and A is equal to 0. But you don't want positive velocity, you want negative velocity. For that reason, I can cross out choice D. So therefore, just by deduction, you're left with choice C. Now, if you really want to reason it out, right? If you look at this xt graph, the first part is 0 because it's not moving, which fits with this piece, V is 0. All of a sudden, the second part here, well, what is your V? V is negative. How do you know that? Because the slope is negative. Well, how do you know whether it speeds up or slows down? Well, the slope here stays constant, so A is equal to 0. So it fits with this condition that C gives us. You start off motionless, all of a sudden you start moving in the negative direction at a constant rate, meaning A is equal to 0. So that's choice C. Okay. All right, let's do this one. Here you're given an xt graph, and once again, you're asked to pick a velocity time graph that corresponds with it. So just learn how to draw tangent lines when you give an x to t graph, and then from there you can tell whether an object speeds up, slows down, and the direction in which it moves. So here I'm just going to draw a tangent line that tells me my vi is 0. I want to draw a tangent line that tells me my v is negative because those slopes are negative, and it's getting steeper and steeper, okay, in the negative direction. So what does that mean? Here I wrote for you steeper equals speeding up. Well, how do you know which way is speeding up? Just look at the sign. These are negative slope, meaning it's speeding up in the negative direction. All right. So if you understood that, v and a must have the same sign. I made that note for you. So in this particular curve, it starts out flat and it gets steeper and steeper in the negative direction. So which means v and a have to have the same sign when an object speeds up. Well, if v is negative, then a also has to be negative. Okay. So therefore, I just kind of made a comment for you here. So if v is negative, therefore a is also negative because they have to have the same sign when the object speeds up. So when the steepness, when the tangent line gets steeper and steeper and steeper and steeper, you can say that the object speeds up in that direction. Well, let's go ahead and do this. Okay. Here, we need a vi that starts at 0, but for graph A, it says vi is times equal to 0. Vi is some positive number, so that's kind of whack. We can cross that out. Okay, if you really want, you can just cross it out. So here, v is positive just because it's above the t-axis. All right, and likewise, if the slope here is 0, a is 0, let's go ahead and cross that out. Okay, I can, as I stated, I can simply cross choice A out just because I need the initial velocity to be 0. But the fact that here at times equal to 0, the velocity positive doesn't match it with 0. Okay, let's do B. B, if you look at this particular graph, it's saying that at times equal to 0, you go down, it's some negative value. But once again, we need an initial velocity that is 0 because the tangent line here starts out flat. So right away, this B is wrong just by looking at this particular piece of information. But I'll show you more. Okay. If you look at this graph just like choice A, how do you know which way is moving? V is negative. Why? Because we need the t-axis. The slope of the sign is 0, so A is 0. But it doesn't match what we need, right? We need VI to be 0, but this is saying VI is negative. We need A to be negative, but this is saying A is 0. So we can just cross that stuff out. It doesn't fit, or doesn't fit. Let's go to C. All right. Choice C, if you look at this graph, VI here does indeed touch the origin, so we can say that VI is 0. So it matches what we need here. However, if you look at this particular graph for C, the whole entire red line is above the t-axis, meaning all the velocities are positive. So I can just say V is positive. Well, how do I know if it's speeding up or slowing down? Well, just by looking at this. The slope of this graph tells you A. In this case, the slope here is positive, meaning A is positive. So once again, if V and A are the same sign, it's speeding up, right? But we don't want it speeding up in the positive direction. We want it speeding up in the negative direction. So this is the wrong graph for direction. All right, let's go to D. If you look at choice D, similarly, if you look at choice D, at the times equal to 0, VI is 0. And as time progresses, the velocity keeps getting faster in the negative direction because this whole entire graph is beneath the t-axis, meaning the velocity is negative. And if you look at this particular graph, V is negative, right? However, what's your A? Well, look at the slope. This is a negative slope, meaning A is negative. So therefore, we can say that the object is speeding up in the negative direction. It's speeding up because V and A are the same sign. All right, so there's your answer. Well, how? Because I need VI to equal to 0. VI is 0. I need V to be negative. V is negative. And I need A to be negative. A is negative. And so choice D is the right answer. Now, if you really wanted to, you can deduct choice E as well, okay? If you look at choice E, it's kind of whack, okay? It's saying the whole entire time V is 0, but that's kind of whack because the fact that this is an x to t graph that is parabolic or curve, meaning your velocity changes, it can't stay the same. This is saying velocity stays the same at 0, motionless. So if it's motionless, therefore A is also 0, but the fact that it's motionless doesn't fit what we need, so I can cross E out, okay? All right, and then for this one, it's saying which of the following position time graph represents an object that slows down while moving in the positive direction. All right, you're looking for an object that slows down while moving in the positive direction. So if you look at this one, if you kept up recently, here, if choice A, for choice A, if you draw a tangent line that extends the vertical, that's the positive velocity. As you can see this graph here, as time increases, the steepness of the line keeps getting flatter and flatter, meaning it's slowing down. So choice A would be an answer choice. Choice B, okay, is whack. If you're slowing down, it implies that you're decelerating, But anytime you accelerate or decelerate, the graph of x at t has to be some sort of curve. The fact that it's not a curve, I can cross it out. Let's go to C. C is a curve. However, if you look at the tangent line for C to start, it started at 0. But then as time increases, the steepness of the tangent line gets steeper and steeper. Well, you're looking for an object that slows down. You want a graph that has tangent line that gets flatter and flatter, not steeper and steeper. So far I can cross out B because it doesn't fit the shape of what I need. C is whack only because I need it to slow down, not speed up. D, for the same reason I cross B out. If it accelerates or decelerates, I need a curve. This is not a curve. I can cross that out. Therefore, I can also cross E out. I can cross G out because these are graphs that are not curved. Well, let's go to F. Well, F here is a curve. However, at times go to 0, the tangent line is flat. Watch my cursor. If you draw a tangent line, it's flat. And as time progresses, the tangent line keeps getting steeper and steeper in the negative direction. You don't want steeper. You want more gradual. This is saying it's speeding up in the negative direction. You don't want speeding up. You want slowing down. So I can cross out F. Let's look at choice H. H here, once again, if you draw a tangent line, watch my cursor, if you draw a tangent line that crosses the x-axis, that is a positive slope. And as time increases, the slope keeps getting flatter and flatter. Well, it's moving to the right. How do I know that? Because the tangent line is a positive. Why do I know if it's slowing down? Because it keeps getting flatter and flatter. So for this particular graph, choice A and H, if you look at it, they're really the same shape that's been shifted down or up depending on your perspective. The fact that I'm looking for slowing down, I need a graph that is more gradual and gradual. It levels off, okay? So for this one, A and H are your answer choices. I hope that helps a little bit. Good luck. Stay nerdy.